Good afternoon, everybody. This is Laura McDermott from Cornell Cooperative Extension talking. I just want to welcome you to the Northeast SARE Professional Development Project, Soil Management and Berry Crops as a Model for Management Education. This is the 11th in a series of 12 in-depth berry crop nutrition and soil management trainings, and we are really happy to have you here. As you log on, if you would please just note in the chat box where you are from and what you work with, that would really help our speaker, who is from the University of Florida, get a better idea of who is in the audience. I expect that we'll have a few more people log on, but in the meantime, I'm going to just show you around. In case you have not been here before, I want to make sure that you're accustomed and familiar with the Adobe Classroom. The web links box at the lower left-hand corner is where you can download, or you can be linked directly to the websites that are listed. The webinar archives and Northeast SARE are listed there. Then in the lower right-hand corner are the files that we would be very happy to have those of you who have not filled out the Northeast SARE Educator Pretest and the Northeast SARE Demographics Questionnaire. Both of these are very important for the grant information, so we encourage you to do that and send that back to Kathy Heidenreich. But let's just allow just a few more moments for people to log on, and then I'm going to go into the second part of the training, but just let me give them another minute or so to make sure that everybody's logged on. I do want to draw your attention to the fact that we're looking for a little bit of input, and at the very bottom of the notes pod, if you scroll down, Kathy has stated that if there's any topics or issues related to berry crop soil and nutrient management that have not yet been addressed, next week on March 6th, March 9th, that is the last webinar for this series. That'll be at 2:00 p.m. and Dr. Harold Van Ness will be leading that. But part of that will be to address any remaining questions that might exist. So I think at this point, let's move into the second portion of the webinar. And I'd like to introduce to you our invited speaker. Dr. Santos, Dr. Bielinski Santos is an assistant professor of horticulture with the University of Florida and IFAS. He conducts research on strawberry, tomato, bell pepper, and increasingly high bush blueberry. He works out of the, I should have read from the other side. I think it's the research station, the Gulf Research Station at IFAS, and he works specifically with fertilizer, irrigation, protected agriculture with those remaining crops, and increasingly blueberries. And that's the Gulf Coast Research and Extension Center. Experiment Center. So thank you very much, Dr. Santos. Sorry if I kind of got that introduction a little bit bobbled, but I'm going to let you take it from here, and people will be continually logging on. I think that Dr. Santos had asked, we spoke about this earlier, if you could hold your questions till the end, or if you want to type them in, go ahead, but we'll take all the questions at the very end of the presentation. So thanks very much, and we'll get started.
Well, thank you, Laura. I really appreciate the opportunity to be here today and talk to a very diverse group of colleagues, both in research and extension. Really appreciate that, and also appreciate the fact that I'm in 80 degrees here in Florida, where it's kind of cold up there. So if you guys don't fall asleep, I'm gonna try the best to try to keep your attention towards this next few minutes. As Laura mentioned, part of my responsibilities at the University of Florida are to direct the vegetables and small fruit horticultural program that focuses on fertilization, water management, protected ag, and cultural practices for most of our target crops that include tomatoes, peppers, strawberries, blueberries, and most cucurbits. Today, we are going to be talking mostly about strawberries and how the fertigation techniques and some of the hydroponics have been experimented here in Florida and abroad also, because part of the activities that we conduct, uh, both research and extension, are not only in Florida but also in California, Spain, Argentina, Chile, and other parts of the world where we have other research being conducted right now. So with with that said, we are going to be focusing today on three basic aspects. And the fertigation by itself, we're going to be talking about a little bit of the concepts of this. We're going to be trying to be really broad on this, knowing that previous speakers probably touch a lot of the aspects of the nutrition and fertilization. Later, we're going to go to the rate determination, which is sometimes one of the most important aspects and what relates to this when it comes to fertigation and fertilization of strawberries in general. And also the third touch aspect is going to be touching on some of the diagnostic tools we are using right now. I've been asked to look into not only the way that we produce strawberries, which is, along with California, very different to the rest of the country. We deal with strawberries as an annual crop. We don't have a second crop or the third crop like in some cases we have in the north. But also some of the emergent technologies that some growers are using, not only here but in other parts of the world, when it comes to fertigation and trying to determine the best way the crops can perform. So within each one of the subjects, you're going to be seeing that we have certain aspects that we're going to be touching. Hopefully, we're going to be kind of thorough about it and give practical examples of what each one of these aspects mean and what we've been doing in Florida with regard to each one of them. So when we look at fertigation, uh, we cannot separate the nutrition aspect from the irrigation practices. And we always tell everybody that if there is one thing that when we talk about fertilization in general, is that there are not certain recipes that need to be followed. Every situation is going to be different, and one thing that you're going to see today is that we are not going to give specific recommendations, blanket recommendations for everybody to do fertigation, as opposed to touching the principles that take you to those recommendations and for you to adjust to your own programs. So when we call fertigation the process by which we apply fertilizers through the irrigation system, and by doing that, we can use two types of specific fertilizers: the ones that are ready to use in a liquid matrix, which is the most common method that is used by the strawberry growers here in Florida and in parts of California. And also we have the hydrosoluble salts. These are solid salts, just diluted in water, similar to the ones that you buy sometimes in the hardware stores, that you go buy a salt and just dissolve it and apply it. Both of them have pros and cons. Obviously, when you're carrying a big liquid matrix of fertilizer, they charge you a lot more for the cost of taking that fertilizer to you, because they're carrying a lot of water with them. However, these are fashion-made formulas that they are tailored to your specific needs, and you just apply the formula. You don't have to worry usually about the formula precipitating to the bottom of the tank unless that is really cold, and you know exactly what you're applying. The problem with the salts, when they're hydrosoluble, in contrast with that, is that usually people, the more that you handle this, the more the opportunity for error, for human error, that you're going to find. Because one day somebody's making the mixes, in a week somebody is going to be doing it, and there might be differences on the fertilizer you're really applying in the field. However, regardless of the formula that you use, no fertilization program is going to be ever efficient if a poor irrigation program is in place. And this is something that we've been formulating to our growers. This second aspect is extremely important. Uh, Strawberry growers in Florida are very efficient handling the water during the season, and that translates into good use of the fertilizer that is applied during that period. Now, uh, we know, and when we talk to our growers, that usually this process is not a simple process that they can do on their own without the education that we carry to them. And one of the principles that we tell them all the time is that nutrients only move as far as the water moves those nutrients. So they have to be clear about that, and that's why a lot of strawberry growers are very, very successful in that regard. However, many of you might be wondering, how they handle fertilization in a situation like they do in Florida. Well, soil, this is a type of soil that we have. It's very sandy, extremely sandy. It's the closest that you're going to find to a beach without sodium in it. And that makes it extremely challenging. And in fact, somebody asked me the other day how we were able to do this, and I just tell them that we take a lot of the hydroponic principles to produce strawberries here because it's the closest to the hydroponic system that you're going to find in real life. When you got these deep sands infiltrate really quickly. And that's challenging to us because when you have a soil like this, when growers apply water and have a crop like strawberries that we grow in an annual hill system like this, when usually we establish the strawberries with sprinklers irrigation, protect the berries also with the sprinklers, and have one or two drip tapes like the ones that you see here at the bottom of this slide in each one of the beds. Um, it creates an opportunity to apply fertilizers in a very efficient way, but at the same time it's challenging because you can have a high risk of leaching fertilizer. And if you don't believe me that, I'm just going to leave you with this picture. When this is a cross section of a bed, sandy bed like we have here in Florida, and the picture on top represents watering that bed with one drip tape for 1 hour. That's how quickly the water moves down without moving farther out on the sides. And that's when we have to challenge ourselves to keep those nutrients within the root zone and making sure that nobody waters excessively so they can be efficient when they apply fertilizers. The second picture at the bottom of the slide represents beds with two drip tapes, and in both cases, this is 1 hour of irrigation. And the top, in that case, we were able to achieve 31% coverage of the bed, of the area of the bed, whereas with two drip tapes, you get barely 67%. That means 2/3 of the bed are being watered when you have 1/3 of the bed that hasn't been touched by water. So you have to be sure that you not only put the right rate of fertilizer, but also the placement of that fertilizer along with the irrigation program has to be efficient for us to make sure that we make the best use possible of the resources that are put out there in the field for producing strawberries. Now, going back a little bit to the principles that we follow here in Florida particularly, we usually tell our growers that they shouldn't be irrigating for more than an hour. And the reason is that those pictures that you just saw, after an hour of irrigation, you're probably dumping most of your fertilizer into the aquifers because they just leach down. Also, another important thing that we tell our growers is that they should have monitoring equipment to make sure that they monitor how much water they have in the beds and knowing when to apply and when to not to apply. Later on, we're going to see some pictures of the type of equipment that is being used right now to make sure that the water is used appropriately. Also, we extensively educate our growers on knowing the kind of soil that they have. They have to calibrate their soil. They have to know what the field capacity is because, believe it or not, all the sands are not equal. There are some sandy areas here that are very fast, very fine sand, that you get the field capacity when the soil is barely in 12%. Whereas there are other areas when you have a heavier type of sand that where field capacity is around 18%. So they need to know exactly what kind of soil they have, and even within the same farm, knowing the pockets of soils that they might have. And I'm going to provide more details later on the broad diagnostic of farms and how growers can section that farm depending on what kind of soil they have. The whole objective of all this obviously is to keep the water in the rooting zone, and to do that we want to make sure that our growers at least have one of these two, or if not both, pieces of equipment that allow them to monitor water in the soil. For that, we have two basic pieces of equipment. Tensiometers, which are the traditional piece of equipment that measures water tension in the soil. They have very decent accuracy, even though we are disputing this more and more because sometimes in the middle range of tensions, you might not have an accuracy that would tell you exactly how much water you should put out there. The disadvantage is that you have to use one unit per location that you're going to be collecting data, and making sure that unit is there and is clean, that it's not collecting algae and anything like that. Extremely easy to use and very inexpensive. However, there are other pieces of equipment like what you see on the right here, which is called a time domain reflectometer, which is relatively expensive. One of these units can go anywhere from 500 to thousands of dollars. It has this handheld unit that gives you an instant reading of soil volumetric water, and has these prongs that go into the soil that can be calibrated at different depths, and it can tell you instantly the volume of water that you have in the soil. Therefore, if you know that your soil field capacity is at 15%, at 6 inches deep, you immediately get a reading that tell you that that's what you have over there. Another advantage of this unit is you can buy one unit or two units for the whole farm. You can have a farm manager just going around and just collecting the volume of water in the soil at the beginning of the cycles or before the beginning of the irrigation cycles. It's very easy to use. However, the downside is they could be a little bit unaffordable for some people. There are other units that are extremely more complicated that are based on the same principle or similar principles, but I think that escapes the scope of what we're trying to do today. We're not trying to do a seminar on how to monitor water, but rather to use practical tools to monitor water in a situation when growers might be struggling to make a profit. So usually when we go into also in farms, we try to make growers aware of the necessity of knowing what kind of cultivars they have. One thing that we found is that cultivars might respond totally different to the same fertilization and irrigation programs. And obviously, varieties that have been bred in Florida will respond different than varieties that have been bred in California, just basically because they've been bred in totally different environments. So the selection pressure will be different, and the situation of the California soils will be different to ours, and that will be true for a lot of varieties that are bred in other regions too. So we've been trying to develop tools that allow us to tailor different formulas for different varieties, and we're going to talk about that a little bit later. Now, when it comes to the second part of the fertigation, soil versus soilless culture, I realized that the vast majority of strawberries in the U.S. are grown on the soil. However, there is a increased movement of people going into protected culture and going into soilless culture within those structures, and that requires also for us to provide knowledge to that increasing group, both for the traditional market of strawberries and also the organic market of strawberries. But for that, we just have to make sure that we know the physical and chemical properties of our soils. If you're doing soils, field capacity, as I mentioned, wilting point, texture, structure, as important as all the chemical properties such as organic matter content, pH, nutrient content, salinity, and cation exchange capacity. We have to make sure that our growers understand that that's extremely important to adjust those fertilization programs. When it comes to soilless culture, you got three different categories of soilless that you're gonna find. You got the solid substrates, which we're gonna talk a little bit in the next slide. We got the pure hydroponics, that are the plants just in a liquid matrix of solution, nutritional solution. And also you got something new that is called, relatively new, that is called aeroponics, when the plant roots are in the air and you get a constant mist of water with nutrients that are sprayed into it. Obviously, of all this, the solid substrates is the most common and the most used, not only here in the US but in other parts of the world. Now, when talking about soilless media, the basic principle is that we are just replacing the natural soil with a lot of these materials. However, many of them are naturally deficient on a lot of nutrients. You got you can pick whatever soilless media is out there, and you're always going to find deficiencies of certain nutrients, and that's when the know-how comes into play. You need to know what kind of media you have. But we know that a good soilless media should provide good root support, good nutrient water retention, allow gas exchange, and also be a pest-free environment, because it's a way for us to get away from the fumigation of the soil and other problems that we may have. Now, when it comes to mineral origin media, you got perlite, vermiculite, sand, and rock wool, which are very common out there. And in the organic side, you got all from very vegetable or animal origin. You got coconut coir, peat, pine bark, compost, different types of compost, all kind of compost out there, and also rice hulls that are usually either used as they are or burnt. Uh, you look at a lot of these materials, and as I mentioned, as I put in a slide before, not necessarily the cheapest is the best. It all depends on what kind of needs you have, what kind of irrigation fertilization program and equipment you might have in the farm. If you have an equipment that you can only fertilize once per day, you might want to make sure that your soilless media adjusts to that type of regime. Otherwise, you're gonna maybe running in trouble. Here in Florida, we have some specific examples of soilless and containers that are being used for strawberry production. This is a grower field here in Florida when we get strawberries growing in troughs, and those troughs are filled with pine bark. All of this with drip tape and fertigation. Also bags almost very close to the soil over these concrete blocks. When we fill the bags with pine bark. Also, you got other growers that have bags that are filled with coconut coir. Usually these bags are pre-mixed and bring the coconut coir, and usually it's imported from Asia. And finally, you have also growers that have been struggling in the past and have tables like this, and they might be reusing those tables for something else, like people that had nurseries before, and we've been converting some of these people to producing strawberries on top of the tables with substrate. Also, other people have been looking into vertical production with these vertical systems. The They might save a lot of space. However, usually when you run into these lower levels, the light quality and intensity is a problem, and strawberries might not flower too well down there. However, from the first two, three, four, five levels, depending on where you are and the type of plastic cover that you have on top, you might be very successful producing the crop. Now, moving on, when we look at the injection equipment uh, for fertilizers, you usually are talking about two or three classical pieces of equipment that are convenient, and some of them are very cheap and has pros and cons with regard to one and to the other. The first piece of equipment that I want to show you is what they call the venturi suction injector. This is a very simple uh, system. However, the problem is that when you have a system like this, you, as the pressure of the line, of the water line changes, you might be changing the pressure and the injection of this each one of these venturies into the line, which is going to end giving you a very variable fertilizer rate that you're going to be applying. So this is a very simple method, very inexpensive for a lot of growers, but they require to monitor the injection of each fertilizer more efficiently than they would do with a system like this. This is what usually the very constant injection. They could be both hydraulic, like the one on the left, or they could be electric, like the one on the right. And there is a company that is called Dosatron. That's where we're taking the name from. No endorsement intended here. But these systems inject a very constant rate at a very broad range of pressure, water pressure. So if you go from 20 psi to 10 psi, you're going to continue injecting the same concentration of fertilizer into the stream, which is going to allow you to have the same rate. It's just that the irrigation and the fertigation process is going to last longer if the pressure drops. So for those of you who might uh, have plenty of money to go into it, especially growers, there are some computerized consoles that do all this for you, and you don't have to mess around a lot with this system because they adjust the fertilization throughout the season by themselves. You just have a program that goes into, but these are a lot more expensive than all those methods. And one thing that we want to make sure is, and take home message, is that more expensive not necessarily means better. Uh, it depends also how you set up your system and how committed you are to be precise in terms of the fertilization that you're going to be applying. In many cases, when you got hydrosoluble fertilizers, you got a multi-tank injection point. When you got one tank for every type of fertilizer that you're going to be applying out there. For example, in this tank in the left, in this case, you got the acids, like phosphoric acid is being injected through that tank. And this one, you got micronutrients that are being injected. In other cases, you got phosphates and sulfates. And in the other one, you have nitrates. The idea for this is that you don't mix a lot of these fertilizers because they can precipitate to the bottom. So if you have a hydrosoluble fertilizer, you need to separate them and make sure that you inject the right proportion of all of them. This is a very common system that is used in greenhouses all over the world when salts are added to water instead of ready to use liquid solutions like we use in the open field in Florida and many parts of California. So moving on to rate determination, which is the second part of our conversation today, you're going to see a lot of now practical examples of how we calculate rates for strawberry production in Florida. I just want to put this slide here so you refreshing to you what the macro and micronutrients are, and a lot of these formulas sometimes might not have all the micronutrients, and they need to be supplemented depending on the soil needs that you have. So, but even more important, even as important as rate determination, also we need to make sure that we know the sources, the placement of the fertilizer, and the timing when all this is going to be done, and to make sure that we sometimes, in some cases, for some micronutrients, like for example zinc or iron or sulfur, we use blanket recommendations because sometimes we don't have specific calibrated tests that will tell you exactly how much we need in a system in that place. Or you might have a piece of land that is brand new that nobody has done any strawberries in that part of the state, and you might need to use blanket recommendations while you calibrate the system. In any ways, when you are determining the specific rate of application, you have to make sure that you take into account the crop requirement, the leaching, the losses through volatilization, and chemical and biological immobilization in the soil. And that's going to give you a rough application rate that you're going to be applying. All these tools we take it into account when determining the best rate for for applying a fertilizer and producing strawberries in our state. Now, at the same time we say that, we mentioned earlier that different cultivars with different growing rates and plant architecture is going to play a major role in how much fertilizer you put out there. So we focus a lot of our attention here in Florida to looking at pre-plant and early N and P fertilization, as well as at the adjustments during the season of nitrogen and potassium throughout the production cycle. To give you a clear picture of what we do in that regard, we concentrate a lot on nitrogen and potassium because these two are the most used nutrients, or the most applied nutrients in our situation. Nitrogen is usually applied 100% through the drip tapes. Sometimes some people might apply a little bit in pre-plant. 6 years ago, this was around 60% of the acreage. Right now, we are only below 20% of the acreage of people that apply pre-plant nitrogen and supplement that with drip later on. Usually the rates were between 20 and 50 pounds per acre of nitrogen that were applied before the drip tapes were in. In the case of potassium, 100% is delivered through the drip tapes. A lot of this has been changing in the recent years because of the environmental concerns that we have in terms of nitrate moving into the groundwaters, and also implementing best management practices for the crop. However, there is no a single best management practice better than rising prices of fertilizer. And sometimes I say that in a way that sounds sarcastic, but that has created a more conscience throughout growers of how to use fertilizer more efficiently because the prices have been going up. In the year 2000, 1 ton of fertilizer was below $200 an acre, the $200 a ton, and right now the fertilizers are above 500. And that has created a conscience of we need to be more efficient applying fertilizer. For a strawberry fertilization, very common fertilization program here in Florida is using 1 to 1.5 pounds of nitrogen per acre per day, which is going to add up to around 150 to 175 pounds per acre per season. Remember, our season starts in October and we are done at the beginning of March. It's a very short season because our market is the winter market. And after that, other states take over the production in the state and we become really hot to produce strawberries. So in that short season, we apply usually between 150 175 pounds per acre. Potassium is a little higher because people have the perception that applying more potassium at the end is going to increase fruit quality, which we're going to try to illustrate you on that regard in the next slides. And also we are more conscious right now about looking at phosphorus in the early stages of production. Now, when it comes to using starter fertilizer for applying nitrogen, we've conducted research in the past where we compare no application of pre-plant fertilizer versus the application of 50 pounds per acre of pre-plant nitrogen using ammonium nitrate as the source. And what we found in that research consistently over time is that there was no significant difference across the board in any of the months when we compare the production of strawberries by not using starter fertilizer or using starter fertilizer at the beginning. And this was done over a period of 3 years. And this is important because it means not only that the growers might be saving around 17 to 20 bucks an acre on the application plus the labor and everything else, but also it's 50 pounds per acre, and you multiply that by 10,000 acres. That's a tremendous amount of fertilizer that was just sitting there and doing absolutely nothing for the crop. So after that, a lot of growers were moving out of the business of applying pre-plant nitrogen to the crop. And what they did is that they started applying, connecting the drip tape as early as possible to the crop and started injecting nitrogen fertilizer as soon as the plant was on the ground. And they did that for the first 10 days. Well, we also conducted research looking at this, but this time we made it a little bit more complicated, and we took two different varieties. Two varieties are standards for us. Florida Strawberry Festival, which is the most grown variety here in Florida, and that is the red line, and Florida Radiance, that is the blue line. And what we found is that these two varieties that had two totally different architectures react totally different to that initial fertilizer rate that you're putting out there. In this case, we compare 0, 0.5, 1, and 1.5 pounds per acre per day in those two varieties for the first 10 days after transplant. We injected that amount and we collected the early yields of the varieties. And what we found is obviously with 0 there was no difference, but there were two totally different patterns as you increase to 0.5 pounds per acre. You can see here that Strawberry Festival continues increasing its early yield as you move to 1 pound and stabilizes after that, whereas with Florida Radiance, the maximum yield was obtained with 0.5 pounds. Those that applied more than that, there were no significant differences from that obtained at 0.5 pounds per acre. That is giving us more confirmation that we need to design more tailor-made formulas for specific cultivars, and taking into account that many growers apply as much as 1 and 1.5 pounds per acre across the board for all the varieties. Now we have to come up with ways to differentiate across the cultivars. And part of the research that we've conducted had a lot to do with that. And that's why you're seeing right there, we look at other two varieties, and then we started applying nitrogen throughout the season, which is different. What you just saw previously was nitrogen at the beginning, starting in the season, and we started looking at nitrogen throughout the season now in two different varieties. And I have to make a note here that this is regardless of the source. We didn't find any significant differences. If we were using calcium nitrate and other nitrogen sources, we were getting similar responses, as you're going to see in a second. What we found again is that there are different responses across cultivars regardless of the source of the fertilizer that you're using. And some varieties like this blue line, Winter Dawn, which is a very small plant, all it requires is 3/4 of a pound of nitrogen per acre per day. Whereas a big variety like Strawberry Festival needs to get at least to 1.25 pounds per acre per day to maximize early yields. When we look at that, we say, okay, what about if we start comparing this to a newer variety like Florida Radiance? And we did a similar study when we were looking at that, and we found that again we had two very different patterns in the two varieties, Radiance and Festival. When Radiance was maximizing at 0.75, 3/4 of a pound, and Festival was getting the maximum at 1.25. So that's giving us extra confirmation. What is even more important, that extra half pound per acre per day, if you were applying it in radiance without needing it, it might mean 60 pounds per acre per season. That's a tremendous investment that you don't need when you're producing Florida radiance. So what about nitrogen and potassium ratios during the season? We've been told and led to believe that by switching potassium towards the end in strawberries, it's a good thing to increase fruit quality. Well, we've been doing studies when we are looking at the traditional grower practice, that is applying a formula like 604 or 704 during the season until mid-December, and switching later to a heavy potassium formula like 406 or 408 towards the end, supposedly to improve quality. Well, research has been conducted in that regard, and what we found out consistently is that plant diameter, when you go in different ratios, 1 to 1, 1 to 1 to 125, and 1 to 1.5 nitrogen to potassium, there were no significant differences across the board. However, when we move to total uh, uh, fruit weight of the plants, there was the same pattern that was occurring with plant diameter, when there were no differences among all the ratios that were used. The same occurred when we look into the soluble solid content or the bricks of the fruit. There were no differences of the ratios. Remember that when I'm talking the ratios here, growers tend to switch to 1 to 1.5 pounds during the end of the season to increase quality. Well, that wasn't needed in any of the three varieties that we tested consistently in the last 2 years here. So there goes that myth that potassium heavy at the end increases the quality and the total fruit number and weight. We did find, and this was expected, were differences across the cultivars, and that was expected. When it comes to changing nitrogen and potassium during the season, we can conclude that we can use the same fertilizer rate throughout the season, provided that you providing the correct rate from the beginning and the plant has developed a very good rooting system to go down there and get the fertilizer that you already have been applying in the beds, and you keeping all those nutrients without the root zone. Now, also, we are looking into making sure that we adjust the practices for specific growers, and that growers design programs that make sense for their needs. Now, how do we design these programs in the sense, and how we monitor all this throughout the season? Obviously, the diagnostic tools are going to be a tremendous help for us. And yeah, I know a lot of the visual assessment has been done during the season, and nothing beats your own eyes. But the problem is that usually when you see a deficiency, it's kind of late. It has taken a toll on the crop, and you see a situation like in this picture on the right. You got a severe deficiency here, and you want to make sure that you get to the plant before the leaves turn this yellow. Uh, Obviously, some deficiencies cannot be seen at plain sight, and we need to monitor nutrients throughout the season. We usually tell our growers that there are several tools out there that they need to make sure that they have, and no specific tool is going to help you to do a one fits all type of diagnostic. Sometimes you need your own eyes out there looking at the field. Also, you need to do probably some kind of colorimetric test. At the same time, you might do the foliar test of to the plants. In the past, the perennial sap has been used. There are severe contradictions out there on when is the right time to use a petiole sap test, and whether this is a really valuable tool to measure deficiencies in plant, because some people argue that when you have high concentrations in the petiole, petioles act as reservoirs for nutrients, and not necessarily means what is going through the vascular tissue to the leaves. So that's one thing that keep an eye on, that not only to use petiole sap as a only test. Other people also look at colorimetric measurements to determine the greenness of the leaves, especially if looking for nitrogen, magnesium, iron deficiencies. And they use this pad meter, which measures the greenness of the leaves. And those are just two of the most common tools that are used out there. However, when you look at the composition of nutritional composition of the leaves, usually nothing beats a good leaf analysis. The downside of this is that obviously by the time you collect the samples and send it to the lab and you get the results back, several days might go by. And that's why the proactive approach of making sure that your solutions are accurate, that you have the right pH, that you have the right electrical conductivity of the solution, which by the way we haven't touched a lot, but usually you get certain targets, like for the pH of the solution you don't want to go above 7.6 or even to 8, nor lower than 6.2, to make sure that you have the right solution out there. It's also going to depend on what kind of media you have. If you're growing in the soil, or if you're growing in a media that captures or retains a lot of those nutrients, that might give you more leeway in terms of what kind of solution you might want to apply out there. At the same time, the electrical conductivity of the solution, you don't want it to be too high. I know that's particularly a problem in places when you have very high EC of the water. For example, here in Florida, in our station, our water is 0.7 decisiemens per meter. The electrical conductivity of our solution. So when we apply fertilizer, we usually don't want to go above 2, because strawberries are extremely sensitive to any solution that is applied to them consistently above 2 decisiemens per meter. So you want to make sure that you keep a balance, and that's going to have a direct influence on what frequency of fertilization you're going to use. If to obtain the given fertilizer rate that you want, it's going to take that solution above 2, then you're probably better off lowering the concentration of your solution and applying it more frequently. So all those are aspects that we work with growers to make sure that they have the right program in place, so they don't go overboard and start seeing salinity problems and pH pH disorders in the soil that are gonna start showing in the plants some of these problems, and also blocking the absorption of certain nutrients. Nevertheless, we have a sufficiency range for strawberries that our university has put together in our production handbook, and we got certain guidelines, not written in stone, but certain guidelines on how much nitrogen, phosphorus, potassium, calcium, magnesium, sulfur, iron, manganese, zinc, boron, copper, and molybdenum the plant needs in a dry weight basis when it comes to adequate range of fertilization. All this is available either through our website here in my program, or the extension website of the university. It is free of charge. It could be accessed from anywhere. If anybody has a question about later on and would like that table to get to you, you can either get a copy of the presentation or to access the website, and I will be happy to direct you to the right spot. Below that table, we have another table. As I mentioned earlier, we use all these measurements, all these diagnostic tools to complement each other. You got a table that also show you the perceived sufficiency ranges for our conditions for nitrate, nitrogen in the petioles, and also for potassium in the leaves. So all that is available at the same time, and both tables are together like that. So We just want to make sure that we design the right programs for our growers. Now, towards the end, and we are in the last few slides here, we want to concentrate also on what it's out there. Um, Now, I know a lot of people use aerial photographs as a tool to diagnose symptoms, and this is extensively used in agronomic crops when people corn, soybean, and other crops out there. And it's a tool that is being used increasingly more in vegetables now, especially when it's growing in extended areas. People are using some more actively nitrification inhibitors just to slow down the process of conversion from NH4 to nitrate. And also, more and more people are using crop refractance measurements is just a sophisticated method to determine the colors of the plant and what is reflecting from the plants. And I know some fellow scientists have been working actively in this, and I wouldn't be surprised in the next few years this method takes is used a lot more extensively in the US. One of the methods that is being used here in Florida, especially for people who have large, very large strawberry areas, talking above 100 acres, is using the aerial infrared photographs. As you can see in this picture, it gives you a good idea of what the high vigor areas in your field are and what the low areas are. And usually that's tied up to the specific properties of the soil or specific practices of that soil. For example, in that specific case, you're gonna see the areas in green that represent the low vigor areas of that field. And reading a little bit of the narrative of this picture, those were areas that were both either poor fumigated or have very limiting drainage situations in it. And this is a tool that is being used more actively now to know what you have in the field and make sure that you make adjustments either on that season or for next season to do amendments pinpointed to specific blocks of land of your field. As you can see here, you got in the left side of this picture, you got 9 different fields, all of them with very different vigor with the same variety. And that allows that grower to say, okay, this is a very low spot, this is a very high spot, or this is a spot that has higher organic matter than the other, and that allows you to make adjustments. Now, towards the end now, we are looking more increasingly into looking at the effect of nutrients and growth and quality, not only the traditional nitrogen and potassium, but also I mentioned that we've been focusing even more on phosphorus now. The reason is because even our soils have a lot of phosphorus available. Sometimes we see phosphorus addition increasing the quality of the plant. And then that's probably because when the young transplant is put in the beds, you don't have enough phosphorus around the root zone for the new roots to absorb it at a given time. So you might have phosphorus in the environment, but might not have it where you want it. So we are working on that too. The other thing that we're doing is working actively on management of soilless culture to make sure that growers have what they need. And every specific soilless medium has specific characteristics, and we want to make sure that we pinpoint to them what are the practices that they need for specific conditions that they might have in the farm. If you got any further questions beyond this seminar, I'm putting my email there, so anybody can feel free to expand over this and discuss this a little bit further, or if any other subject was left out, I will be more than happy to answer your question. Just allow me a couple days for it because I keep traveling all over the world, so sometimes I might not even be in the country when I might be answering some of the questions, but I will be happy to do it because this kind of exchange with people from other states, con colleagues, researchers, and extensionists, is what enriches the process of gaining knowledge and generating technologies for our growers and all the growers in the U.S. With that, I'm going to leave it for questions, and I appreciate your attention today and your patience with all this presentation.
Dr. Santos, thank you so much. This is Laura speaking, and we do have a couple of questions that people have typed in. I imagine there's a few other questions out there. So those of you in the audience, go ahead and if you have them, please type them in. I have a few. But first, Jeff Miller asks whether or not you've compared the use of calcium nitrate with urea or ammonium sources of nitrogen for trickle solutions.
Well, that's a great question. And as I mentioned before, we've compared those sources and talking about calcium nitrate and ammonium sources, and we have found no significant differences in the way that it's used for strawberries. Now, if we were talking about other crops, it might make a whole lot of a difference, especially blueberries that we know that respond a lot better to uh, NO3 sources than rather than ammoniacal sources. But in the case of our strawberries and the way that growers handle it, and the rates that we use, we haven't found any significant differences across the board.
All right, thank you. And the beginning portion of, you started talking about ratios of N to K, where K was less than a 1-to-1 ratio. You were talking, I think, more about K being a higher ratio, but can you mention if you checked those ratios where K was actually less?
Yes, we have checked those ratios before, and we decided to leave that out of the research because in preliminary studies we found out that those ratios that correspond to less than 1 pound per acre per day of potassium really start taking a toll on the plants. So usually from the condition that the growers have here and in California, growers tend to over apply fertilizer, not to under apply. And but by looking at those ratios, the preliminary stuff research that we conducted told us that yes, we didn't need to go lower than that, but rather to compare 1, 1 and a quarter, and 1.5 pounds of potassium during the season, which is the most common practice for those growers here.
Okay, and then we have one more question, and I think you mentioned that the goal for the pH of your solution would be a 6.2 of a low, and then the maximum would be somewhere between 7.6 and 8.0.
That's correct, and those are the extremes. And you try to have a nutritional solution that doesn't go below 6.5 and doesn't go higher than 7.3 or something like that. If you have to deal for a short time with a solution that is 7.6, 7.8, it's not the end of the world. But that tends to accumulate over time. So for a given point in time when you're applying that, you might be fine, especially if the plants are big and vigorous, they can take it really well. However, you try to stay close to neutrality as much as possible.
Okay, wonderful. We have another question